Okay, good morning, students. Am I audible?
Good morning, sir. Yes, sir, audible.
Okay, thank you. We'll start with the today's class. In the previous class, I hope screen is also visible.
Yes, sir.
Okay. So in the previous class, we started with our module 4, wherein we need to discuss about VHDL, latches, and flip-flops. And we have started our discussion with a brief introduction to the VHDL. And I have told you what is VHDL, what are the features of VHDL, what are the 3 modeling styles of VHDL, and how exactly signal assignment statement is used in VHDL. And also, I had told you to conditional signal assignment statement like when else and with select. Right. So we'll proceed further in this class and we'll see how we can write a complete VHDL module or a VHDL program. Before I start with, can anybody tell me what exactly are the 3 objective, 3 modeling styles of VHDL? Anybody remembers the 3 description styles or the 3 modeling styles in VHDL? Yes? Yes, Sahil?
So data flow, structural, and behavioral.
Data flow, structural, and behavioral. Very good. What are the features of this 3 modeling style? Data flow modeling style means what? Yes?
So I don't remember.
Don't remember. Omkar, can you tell what is the feature of data flow modeling style means? What exactly you will be using in this? Yes? I told data flow modeling style is one wherein the digital circuit is described by logic equations. Is that clear, Sahil? If you use logic equations, it is called as data flow modeling style. And if you
Yes.
want to implement the digital system or digital hardware by using its truth table, then it is called as behavioral description. And if you implement a design interconnection of different logic gates or components, then that modeling style is called as what? Structural modeling style. I hope all of you should remember these 3 modeling style. This introduction already I have given to you. Behavioral, data flow, structural. Have a quick look at the slides because I have not used the slides in the previous class. So you can just have a quick look, then we'll proceed further. This example already we have discussed, wherein we have 5 different signals A, B, C, D, E. Out of this 5, A, B, D are the input signal, E is the output signal, whereas C is A, B, D are the input signals, E is output signal. C is called as what? It is acting as what? Both input as well as output. So such signals are called as in-out signals. So there are 3 different types of signals you can see in VHDL. Input signals, output signals, and in-out signal. So here A, B, D are called as input signal, E is the output signal, and C is called as in as well as out. It is out for the first gate and in for the second gate. That's why C is called as in-out signal. Okay. So that's what the 3 modeling style which we have discussed in the previous class is summarized in this particular slide for the same example of AND and OR gate. How do we write behavioral? How do we write the data flow? Then how we write what is called as structural modeling style. In structural modeling style, we use a keyword called port map. As the name itself indicates, it will be mapping the signals mentioned in the parenthesis with the actual signals of that particular gate which you are using. Gate 1 and gate 2 are the labels, and 2 is 2 input AND gate, or 2 is a 2 input OR gate. So this less than or equal to symbol is used as a signal assignment operator, and optional delay can be added, and there are 2 types of delays which we already discussed in the previous class called inertial delay and the transport delay. 2 types of delay in VHDL are called as inertial delay and the transport delay. These examples again already we have discussed. If delay is not mentioned, then the assignment will not happen immediately. It will take very small amount of time. that time is called as delta delay. And if you mention any specific time, then the assignment will happen after that particular time interval. But the execution will happen immediately. Assignment will be delayed by the amount of delay you mention in the instruction, and if delay is not mentioned in the instruction or the statement, then it takes a small amount of delay called delta delay. Right. So structural description, every time whenever you use the port map statement, a copy of component will be instantiated using that component instantiation statement. So here, in order which you have written the signals, the same order you have to use, because it is positional mapping. One-to-one mapping will be done with the actual variables or the actual signals. Right. So then these are already we have discussed about what are the identifier name, how you can use which is valid identifier, which is invalid identifier, and all. And generation of clock also we have studied this. If you connect the output of the clock that is not gate back to the input, and whatever delay you introduce, that much amount of time period the signal will be on, and a similar period it will be off, so that we can get a symmetrical square wave which can be used as a clock signal as shown in this particular diagram. Right. So since if you don't mention the time, because here we have written clock equal to not of clock after 10 nanoseconds. So after every 10 nanoseconds, the state will be changing. But if you write here clock is equal to not of clock, what happens here is after every delta, the output will change. Immediately output will not change. So at 0 plus delta, first value will be assigned. Then at 0 plus 2 delta, second value will be assigned. That is every time the value goes on complementing. So on off or 0 1 0 1 signal you are going to get, and that can be used as a clock signal in the digital systems. So after delay creates an inertial delay, as I already told. So it acts like delay by a specified time. And normally the time is measured in nanoseconds, or you can change it, you can make it picosecond, femtosecond also. Right. So this is the inertial delay. If you just write C is assigned with A and B after 10 nanosecond, this type of delay is called as an inertial delay, which is similar to the propagation delay of the gate or the gate delay. Right. And there is one more type of delay called a transport delay. So if you want to incorporate the transport delay, then compulsory you have to use the word transport. That is, C is assigned with transport A and B after 10 nanosecond. Simply if you write A and B after 10 nanosecond, that type of delay is called as inertial delay. And if you write C is assigned with transport A and B after 10 nanosecond, then that type of delay is called as a transport delay. So there are two different types of delays in Vhdl. Those are called as inertial delay and the transport delay. So this example also already we have discussed, wherein I have shown like what exactly you mean by concurrent execution. Can anybody tell me what is the meaning of concurrent execution? Because that is what is the specialty of hardware description language. And that's where we can't use the normal programming languages like C, C++, Java, etc. Because hardware executes concurrently, and the concurrent execution is a very important feature of the hardware description languages. Right. So concurrent execution means what? Only those statements will be executed wherein event will be happening on any of the input signal, or in short, whenever in any statement, if any of the input signal changes, only then that particular statement will be executed, and that type of execution is called as concurrent execution. So here I have written three statements D, E, F, and you can see there in all the three statements input or a variable or a signal A is present. So whenever signal A changes, all the statement will be executed concurrently. Whereas if only B changes, then only the first statement will be executed, second and third statement will not be executed. That type of execution is called as concurrent execution. And you can have the signal of type bit or bit vector. Bit vector is like an array, which I already told to you. if you assign more than one bit of value to a particular signal, then you have to declare that signal of type bit underscore vector. And if you declare a signal of type bit, it can take only a single bit value, that is 0, 1. So if you want to have strings of zeros and ones, then you need to declare that particular signal as a bit underscore vector. So it is like a one-dimensional array. Right? That's what the importance of declaring it as a bit vector, and a bit is shown here. So if you declare it C, A, B as vectors or arrays, single dimensional arrays, then you can write C is assigned with A and B, where all the three are what? Arrays. Like C is a 4-bit array, A is a 1 4-bit array, B is another 4-bit array. So the operation on both these arrays will be performed, and you will get the answer, 4-bit answer, and that 4-bit answer will be assigned to the signal C, which is again a 4-bit array. Here, instead of calling it as array, we call them as bit vector. Okay. Then we have seen how we can model a multiplexer. How multiplexer can be modeled by data flow description. So already you know that here I have shown 2:1 mux with inputs I0 and I1, select line A and the output F. So F is assigned to I0 when A is 0, and F should be assigned to I1 when A is 1. That is the functionality of 2:1 mux. So same thing can be written when A is 0. What you should get is, when A is 0, you should get I0 assigned to F. Right. So when A is 0, this should come here, and when A is 1, I1 should come here. So A0 means A bar I0. A1 means A I1. So we can write the logic equation for 2:1 mux as F equal to A bar I0 plus A I1. So how do you translate this in VHDL? Is shown here. F is assigned with, this is signal assignment operator, less than or equal to, not A, means A bar. You are performing not operation on A, so you are getting A bar. Then AND operation of that not of A with I0. Since you have put it in parenthesis or in bracket, this will be calculated separately. Then this will be calculated separately, and finally the OR operation of both the brackets will be performed to get the signal F, and here this F will be the output of this 2:1 mux. Depending on the select line A, it will give you either I0 or I1. The same equation which you have written by using a simple signal assignment statement. This is called as simple signal assignment statement. The same signal assignment statement can be converted to conditional signal assignment statement called Vhdl. Vhdl is one conditional signal assignment statement available in VHDL. So how we use this Vhdl statement is shown here. If you don't want to write this normal logic equation, if you want to make use of conditional signal assignment, you can write F is assigned with I0. When you should assign I0 to F? Yes. When A is equal to what? 0. When A is 0, only then I0 should be assigned to F. Else what you should assign? I1. So the same like statement, VHDL statement, what you have written can be replaced by this when you make use of Vhdl statement. So the mux output is I0 when A0, else it is I1. So in the conditional statement, I0, I1 and F can either be a bit or a bit vectors. Here we have to declare it as of type bit, because I0 is single bit, I1 is single bit, A is also single bit, and F is also single bit. If you want to implement, say, 2:1 mux, but inputs are 4 bits. I0 is 4 bit, I1 is 4 bit, and F is also 4 bit. In that case, what you need to do is, you have to declare A as a type bit, and these three signals, that is I0, I1 and F, you have to declare them of type bit vector 3 down to 0. If you declare bit vector 3 down to 0, you are declaring them as a 4-bit vectors or a 4-bit array. So when A is 0, 4-bit value I0 will be assigned to 4-bit F, and when A is 1, 4-bit value I1 will be assigned to F. So by making bit vectors, we can implement the mux with multiple bits as an input and multiple bits as the output. Okay, that is a Vhdl statement. So the general format for the Vhdl statement, which again we have discussed, I have given it once again here. You can see the conditional signal assignment statement Vhdls. You can have signal name, and already I told how a signal name should be given by using alphabets or digits and only underscore. No other symbol is used or no other special character is used. So give signal name, then this is called as signal assignment operator, expression 1 or a value 1 when condition 1, else expression 2 when condition 2, else expression n. So you can have, if you want to assign one among the several values, you can go for this Vhdl statement, similar to your if-else statement or a case statement in your C programming. That is called as Vhdl statement. So cascaded 2:1 muxes, you can see here. What you have to get here is when D is 0 and E is 0, what you should get? The C should come to the output, and when D is 1, right, and E is 1, you should get A as the output, and that is what is written using the Vhdl statement. You can see that F is assigned with A when E is equal to 1, else it is assigned with B when D is 1, and if both are not 1, in that case the value C will be assigned to F. So this is how we can make use of this Vhdl statement to implement this cascaded 2:1 mux. Then one more example is given here, right? 4:1 mux. So in 4:1 mux, what happens? There are 4 inputs and 1 output and 2 select lines. So depending on the select lines A and B, one of the 4 inputs I0 to I3 will be given to the output. When A is 0, B is 0, I0 will be given to the output. Similarly, when A0, B1, I1 will be given to the output, and when A1, B1, I3 will be given to the output. So the logic equation is written there. What is the logic equation for the 4:1 mux, which you already studied? F is equal to A bar, B bar. That means when A0, B0, I0 should come, or A0, B1, I1 should come, or A1, B0, I2 should come, and when A1, B1, I3 should come. This is the logic equation for 4:1 mux, which I already studied in the previous module. Right? Now, how we can write the VHDL equivalent statement for this? So whatever the statement you are having, you can just implement this, right? And this is what is the statement that you are going to get for 4:1 mux. F is assigned with not of A and not B and I0. That means not A and not B. Then you have to give the value I0. Similarly, or A0, B1, then I1. Not means 0. And if you take that variable as it is, means its value should be 1. So this is how we can write the equivalent VHDL statement for 4:1 mux. Right? All of you getting this? This in fact already I have covered. Once again I am repeating. Now I want all of you should write the same VHDL statement using Vhdl statement, which I have explained. Here I have told you the Vhdl statement. This is the syntax for the Vhdl statement. How this Vhdl statement can be used to implement this 4:1 mux. Can anybody tell me what is the equivalent conditional assignment statement? This is normal, simple signal assignment statement. Now the same statement I want you to implement using what is called as when else statement. Can anybody tell me how when else statement can be used to implement the same equation for a 4:1 mux? Yes. Can anybody tell me the answer? When else statement, how can be used? Means you have to assign. F is assigned with I0. When? You have to write that condition. When A equal to 0 and B equal to 0. Similarly, else I1 when A0, B1. Else I2 when A1, B0. Else I3 when A1, B1. That is what is a when else statement. And it can be done by 2 ways. You can take A and B individually, individual values can be assigned, or you can concatenate both A and B and you can use one signal as the condition. So can anybody tell me? In fact, I have told this in the previous class. Yes? Can anybody tell me the equivalent Vhdl statement for this particular expression in Vhdl? Yes? Sohan? Yes, anybody? Okay, at least give a try. I have given you the answer. Can someone tell me the answer for this? Okay, I am going a bit fast because this is already covered, but I know many of you have not understood it well, so I thought I'll explain it once again with the help of these slides. Yes? At least can someone give a try how we can write this statement? Already statement is there in front of you. You have to write it using Vhdl statement. Yes? Richa?
Yes, sir.
Yes, can you write the Vhdl statement for this? Just tell me how you should write. Again, you have to write F is assigned with. How you should write? This is the syntax for Vhdl statement. You have to use this and you have to write the Vhdl statement for this particular signal assignment statement. Yes? Anybody? Nobody, right? So it is given here, you can see. Conditional signal assignment for the same is shown by different ways. 3 different ways I have written the code for the same using Vhdl statement. In first statement, what I have done? At least can you explain this, Richa, now? First one. So same conditional signal assignment I have used in 3 different ways. Yes? And then we are going to see what is the next statement. What is happening in the first statement? At least try to explain that statement which is there. How many statements I have written in the first column? Can anybody tell me how many statements I have written in the first column under the heading conditional assignment statement? Yes? Swapnil, how many statements I have written there?
Sir, 4.
4 statements. Next, anybody? Kiran? Akash?
Sir, only one, sir.
Only one. Why?
Sir, we are checking the.
No, that's what I told. No, one simple thumb rule you should remember. How many statements are there? That very easily you can find by checking what? Yes? If you have written any VHDL code and if you ask how many statements this particular code is having, what you need to check?
Semicolon.
Exactly. You should check how many semicolon you have used. Because I already told semicolon indicates end of the statement. Semicolon is a statement separator. So how many semicolons you have used here?
Only one, sir.
Only one. That means this is considered as only what? One statement. You should not say that 4 statement. Of course, out of the 4 different values, you are assigning only one value. But entire operation is done by a single statement. That's why it is called as conditional assignment statement. So how it works now, you can see F is assigned with I naught. you will assign I0 to F when A and B are what? 0, 0. You have concatenated A and B using the ampersand operator. When the value of A and B together is 0, 0, you will be assigning I0 to F. Like that, if it is 0, 1, I1 will be assigned. If it is 1, 0, I2 will be assigned. Or else, if it is not 0, 0, 0, 1, 1, 0, means obviously it is 1, 1. In that case, I3 will be assigned. So it is called as a single statement wherein we have used the concatenation operator. Now, can you tell me what is the difference between the first column and the second column? Same statement I have written again in different way, but there also I have used conditional signal assignment only. Yes? What is the difference between the first and second? It is almost same, but the way in which I have written the condition part is different. In the first, we have concatenated and we have written it as a vector. And you can see when it is a vector, we have to write within what? Double quotes. And when it is a single bit value, you have to write it in single quotes. 0, 0 is considered as a 2-bit vector, whereas 0 here is considered as a single bit value. So F is assigned with I0 when A is equal to 0 and B is equal to 0. Right? Similarly, A is equal to 0, B equal to 1. Same we have written, but we have not written in terms of a vector. Individual bit values we are checking. That is the only difference between the first and second column. In both this, we have used what is called as the conditional signal assignment statement, valence. Is that clear at least? Now all of you understood? All of you understood how valence statement can be used, which is called as conditional assignment statement. Clear?
Yes, sir.
Yes, sir.
Okay. Then the last column I have explained you with select statement, which is similar to conditional signal assignment statement. With select. It is called as with select statement. So here what I have done is we are computing a value called SEL is one signal. SEL is assigned with A and B. So what this statement does? This is a simple signal assignment statement. What it does? It will simply concatenate two signals A and B. A is 1 bit, B is 1 bit. Those two 1-bit values will be merged or concatenated together, and you will get select as how many bit?
2-bit.
2-bit. Right. So how this can be used now? You can see here. F is assigned with I0 when 0, 0. You need not write now what is that, because before you write this, you have to write this with SEL select. First, you have to write this with SEL select. After writing this, you have to write EF is assigned with I0 when 0, 0. When 0, 0 means when this select is 0, 0. Then you have to put a comma. It is assigned with I1 when select is 0, 1, comma. I2 when select is 1, 0, or I3 when select is 1, 1. So this statement is called as selected signal assignment statement, or it is called as with what? Select statement. This is called as with select statement. The expression for the with select statement is given. You should start with keyword with, then some expression or the a variable or a signal with expression, then keyword select. Then you have to write the signal name is assigned with the value 1 or the expression 1, optional delay when choice 1. It is exactly similar to your what is called as case statement in C programming, but the syntax is slightly different. How you use the case statement exactly in the same way with select statement can be used in Vhdl. All right. Okay. So after knowing this, now we'll go to what is called as the actual Vhdl program module. How is the structure of the Vhdl program? As already told, every Vhdl program will have entity and architecture pair. Whenever you want to write a Vhdl program, you need to have an entity as well as architecture. Right? So what is entity? Entity is like the black box description of your design, and architecture is how exactly the interconnection of the different signal is done. So you should have an entity and then you should have the architecture for every VHDL program. So how the entity is declared then? Entity declaration part is shown here, right? So you should have keyword entity, then some name to that entity, then keyword is. Then you have to use keyword port and you have to write all the interface signals. And then you have to write end entity or end entity name. Right. Then the next part, you have to start with the keyword architecture. Then you have to give name of that particular architecture and you have to use keyword of to mention this architecture is for which entity. Because you can have more than one entity and a single architecture or more than one architecture and a single entity. So you have to write architecture name for which entity, then keyword is. If there are any declarations, those declarations can be done after the keyword architecture, and then the begin of the architecture, you can write the architecture body, and lastly, you can write the end architecture. So every VHDL program should have entity and architecture. So again, I am declaring entity is like declaring the black box view of your design, right? Block diagram of the design. So in that block diagram, you will be mentioning only what all inputs are there, what are outputs are there, and what is the type of the input, what is the type of the output. Whereas in the architecture, you will be describing how those inputs and outputs are interconnected. That's why the name architecture of that entity is. Then you can write the interconnection and you can assign the output signals based on the input. So every VHDL must specify an entity and an architecture at the top level. Right? And for every component also, you should have the entity and architecture. So whenever you are declaring an entity, it should include list of all the interface signals that can be used to connect other modules or to the outside world. You have to declare all the input and output signal in the entity declaration. Right? The interface signal declaration can be used by using what? The signal name colon equal to initial value, that is optional, and then you have to write the type of that particular signals as either in, out or in, out, which I already told. Input is indicated by keyword in, output signal is indicated by out, and if it is input as well as output, it can be declared as in, out. For example, one example is shown there, port inside the bracket a comma b colon in integer. So what information you will get from this? Can anybody tell me? I have declared in the entity a comma b colon in, then integer colon equal to 2. For a time being, you forget about this colon equal to 2 because it is optional. It will not be there everywhere, but we'll write normally like this: a comma b colon in space integer. What it means? Here you are declaring two signals A and B, and the mode of these signals is input and type of these signals is what? Integer. And in addition to that, you have assigned initial value 2 also. It is like in your C programming declaring int A equal to 2 comma B equal to 2, or int like int A int B you declare and optional initial value. So if you are declaring integer A, you write only int A semicolon. Here you can write int A colon equal to 2. There if you want to write assign two values, what you write? Int A equal to 2. So that initial values also can be assigned here in VHDL also. Similarly, C and D are declared as out and type bit. So you can declare integer, you can declare what bit, or you can declare bit vector signals here in this. That is done in entity part. Then what is architecture? In architecture, the declaration section, we can declare all the signals, components, variables used. That is optional. If you want to use any additional signals apart from input and output, those signals can be declared in the declaration part of the architecture. Then the main part of the VHDL program is architecture body. The architecture body contains statements that describe the actual operation. Then for component declaration, similar to entity we'll use, I'll come back to it. Now we will try to write the VHDL code for the same simple. Instead of going to this, I will take first, we will write the VHDL code for a simple 2 input AND gate, right? So we'll see how we can write the code for a 2 input AND gate. Fine. I think the board is visible for you people. Is the board visible?
Yes, sir.
Okay. So I want
Yes.
to write a VHDL code for 2 input AND gate. So I'm writing, this is my 2 input AND gate. I will write A, B, and F. And I want to write VHDL code for this. So how do we write the VHDL code? Can anybody help me in writing this code? How many of you understood the concept of entity and architecture? Can anybody tell me what do you mean by entity in VHDL program? Yes, Sima. What is entity?
It is a input and out, all the input and output information in that. What is the input
Okay.
and output and all will understand.
Okay, it gives you the black box view of that particular design. Fine. And what is architecture?
In that detail, we have to write what is input and all
What
explanation
is
about
that
everything.
information you are giving in entity? In architecture, what you are doing?
We have to declare it everything.
In architecture, you are actually defining how exactly those ports which you have declared in what is that
How?
entity are interconnected. The interconnection of these is explained in this part. Okay.
Okay. Yes.
So how do we write now code? I want to write the code for 2 input and gate. So from where I should start? Yes, Saundarya, can you tell me what I should write first? You are writing VHDL program for this now. I'm starting with a simple program. Already I have given you the structure for the VHDL program. Now I should start with what first?
Port.
First port directly. Yes. What I should write first? Always you should start with keyword what?
Entity.
Entity. I have given you the syntax. Entity name is, then port, and then end entity. So entity, what name I will give now? Say I will get and to underscore gate. I can give some name. Any name you can give following the rules of identifier. Is that clear? Entity and to gate is. Right? Next, you have to write what? Port. Next, after writing port, what we should do? What I should write in the port now? What are the inputs you have taken? A and B, and F is the output. So what I should write here?
A comma B.
Comma B colon what?
In bit.
In of type
Bit.
bit. Single bit values we are giving, right? In of A and B are of type input, of mode input and type bit. Then you have to put semicolon. If there are different types of signals you are defining, compulsory you have to use the semicolon. And then you should write what?
F.
Next, what you should write?
F.
F. Output.
F colon
Out bit. Out bit.
out space bit. And then you should put what? Parenthesis, and then you put the semicolon. You should not put the semicolon after writing the last signal. Complete the parenthesis, then put the semicolon, and then you can write what? Next, what you can write? Simply
End.
you can write end, or you can write end entity, or you can write end what? And to underscore gate. Is that clear? And you have to put again semicolon here. That indicates end of that particular entity. I hope all of you understood this. How to write the entity. This is very important for every, because normally in your exam also, minimum 1 or 2 simple VHDL program they will ask you to write. So you should able to write, And as I already told, in your laboratory also you have to carry out these like the programming exercise, you have to simulate them, right? So this part you should not neglect. Though we are not discussing in detail, whatever is required, you should understand and you should able to execute the programs in your lab also and in exams also if they ask you to write the. Any doubt here in writing the entity?
No, sir.
In what information you can get from this part now? If I ask you to read that and tell me what information you are getting, what information you are getting from the entity? You don't know what is the design is. Okay, don't go by the name. So we have given a meaningful name here, right? But what information you are getting from the entity?
A and B are input and
A
F
and
is
B are input of type also you will get. There is a design or there is a program you are writing wherein what? There are
Two inputs.
two inputs A and B of type bit, and there is a single output here that also is of type what?
Bit.
So that information you have got from this particular entity. Next, this is half part of your program, right? Because I told every VHDL module consists of two: entity, architecture. So entity architecture pair should be there for every program. Now next part we have to write architecture. So how do I write that architecture part? What I should write? Yes, Shreya. What I should write? Yes. Shreya, are you there?
Yes, sir.
What I should write next?
So architecture.
Architecture. Fine. ARCHITECTURE. Architecture.
Then next
Then
we should define it. Means like
what?
detail.
No, only architecture. What is the syntax of architecture declaration? How we should write? Only architecture I have to write. Like entity and two gateways you have written. Now I have to write architecture. Architecture.
Name.
Name. I'll give some name. ARCH1 of what? For whom you are writing this architecture? Some name I have given. Any name you can give. You can put your name also there. So architecture ARCH1 of
And two underscore gate.
yes, and two underscore gate. Then keyword is not semicolon. If you put semicolon there, it is like ending the architecture there only.
Yes,
Like
sir.
normally when you write the for loop in C programming, if you
Yes.
put the semicolon at the beginning of the for loop itself, it will be terminated there. Same thing here, so you should not put the semicolon. Architecture name I have given arch1 of and two underscore gate is. Next, if any declaration, if you want any additional signals, you can declare them. Otherwise, if no additional signal, directly you can start with what keyword?
Begin.
Okay. Next, what I should write?
F is equal F assigned.
Yes.
B.
F is assigned with
A and
what?
A.
And is a keyword in VHDL. A and B
Semicolon.
Right? F is assigned with A and B semicolon. Or if you want to include delay, you can write that delay. A and B after 5 nanoseconds. A and B after 10 nanoseconds, etc. And then
End.
what?
ARC1.
R1. That completes the complete VHDL code for the two input what and gate. The two input and gate. So any doubts here? All of you getting this? All of you getting this or no?
Yes, sir.
Yes. Any doubts? If you have, you can ask. This is very simple, in fact, very interesting, writing the VHDL codes for the digital system. If you have any doubts, you can ask before we proceed further, because now I want you people to write one simple code before I proceed further. Here, if any doubt is there, you can ask. Is there any doubt? All of you understanding? I am seeing today first time a few people are attending. Are you getting it? All the 4 members are there. Sana, Aditi, Abhay,
Yes, sir.
Karthik.
Yes, sir.
Are you getting?
Yes, sir. Yes.
Yes, sir.
Karthik, what about you? Are you there, Karthik? Yes, all of you understood this? Okay,
Yes, sir.
if you understood, I want you people to write a VHDL code for the circuit which we have taken, which we have considered as example in the so many cases. I want all of you to write quickly the VHDL program for this. Screen is visible? Is screen visible?
Yes, sir. Visible.
What you are seeing in the screen, on the screen? What you are seeing on the screen? Arey, tell me now what you are seeing on the screen. Are you seeing that circuit which we have taken in the previous example to explain the concept of concurrent execution? Yes or no? Yes? Arey, what happens to all of you, man? Suddenly no response. You are getting that this thing, no circuit you are seeing on the screen.
Yes, sir.
Okay, good. Now I want you people to write the VHDL program for this circuit. If you understood this code, it is there on the board. You can pin that screen and check it. Both the screens are visible to you. Whichever screen you want, just there is one pin symbol. If you pin that, you will get that particular screen. And quickly, I want you people to write the VHDL code for this. And I want few of you should show the code in front of the camera so that others should able to see it. Right? You should start with entity. You can write entity circuit 1. This is first circuit for which you are writing the VHDL code. You can write entity circuit 1 is, then declare all the input outputs, then write architecture ARC1 or ARC2 of circuit 1 is, and if you need any signal, you can declare the signal and then you can write the architecture. So one important thing that you have to remember here, when you are writing the architecture or entity for that matter first, in the entity, you have to write only the input and outputs of that particular design. Now, if you take this particular circuit, which I have given you to write the VHDL code, how many inputs you are having there and what are the inputs? Yes?
A, B, D.
A, B,
D.
yes. Say loudly. A, B, and D are the inputs. And which is the output?
C and D.
Which is output?
E.
C. You should consider, that's what I am telling. When you are writing the entity, you have to consider that circuit as a whole. So if you take that circuit as a whole, there are 3 inputs, A, B, D, and one output, that is E. Then you may ask, what is C? Where we should declare the C. C is what? It is an intermediate signal. It is not the part of input or output. So such signals you have to declare within the architecture before begin by using a keyword signal. So you should write signal C colon bit semicolon in between the keyword architecture and begin. That is the additional thing you need to do here. So I hope all of you understood it. Anybody have written the code? Can you show it? Who has written the code? Akanksha? Do it
Yes,
fast.
sir.
Written? All of you understanding this or not? Writing VHDL codes? Yeah, someone is showing Kiran. Yeah, can you bit zoom it? I'm not able to see. Yes, very good. Entity. Okay, first I'll just pin your screen so that I can see it properly. Entity 2_gates is fine. Port A comma B comma D colon in bit C colon out bit. Right. So actually these in, out and all are keywords. Always you write them in small letters. Okay. Port A comma B comma D in bit and then out where you have written. Okay. C E colon out bit. Very good. Next. He has written architecture. Good. Next. Architecture gates of 2_gates is. Very good. Next. Before you write begin. Very good. Signal also SIGNALs small letters you write. Signal C colon bit. Means here what you are doing is you are using C as a signal of type bit. Then begin. C is assigned with A and B, E is assigned with C or D, then end of this. Very good. Very good, Kiran. Yes, anybody else has written? Yes. Anybody else has written the code for this? If you have not written the code is here, just go through it. Whatever the code Kiran has written, the same code I have shown here. I think it is visible for all. Vhdl module with 2 gates have written. Entity underscore 2 gates is. Then port A comma B comma D colon in bit, E colon out bit, end 2_gates. Then architecture gates of 2 gates is signal C colon bit. Begin. C is assigned with A and B. And you can see there how the comments are written by 2 dashes. Whatever you write after 2 dash, that is considered as comment here. And then end gate. So this is how we can write the Vhdl code. Any doubts here? All of you understood? All of you understood this? Okay? Oh. I mean, there is no response. I don't know whether you people are understanding it or simply I asked the question whether you understood it or not. You should tell either yes or no, but there is no response from your end. Anyhow, I have just given you the brief overview of the Vhdl and how simple program can be written. In the next class, we'll write some more Vhdl codes so that you will be well versed with the coding part of the Vhdl. With this, we'll end today's class. If you have any doubts, you can ask me before you leave the meeting.